Greetings everyone. I would like to welcome all of you to our group presentation. My name is Yasser and my teammates and I from University of Sharjah will be presenting our project titled Police-to-Vehicle LiFi Communication. The table of contents for our presentation is as follows. Starting with the problem in hand, road traffic accidents continues to be a major developmental issue, a public health concern, and a leading cause of death and injury worldwide. Statistically speaking, 10,000 crashes occur annually in UAE, resulting in approximately 2.7 fatalities per day. In addition, road traffic accidents and injuries are costing UAE's economy 20 billion dirhams, according to research made by Gulf News. As well as 12 million traffic offenses were recorded in UAE roads only in the year 2019. Although traffic violations have increased by 46% in the period of 8 years, it did actually limit and drop the number of crashes and injuries in UAE. The main reason behind this improvement is the measures and technologies adopted by the Road and Transport Authority in UAE, such technologies as the new radars and speed cameras. But as advanced as these radars and as much as they aided in reducing the numbers of accidents and crashes, however, they remain imperfect because they do not provide real-time warnings. Usually, the fine will show up in your account in a range of 24 hours up until 3 days, which is a long range. Today, the novel approach that we're proposing is to implement a mechanism of communication between police vehicles and other vehicles using LiFi technology to immediately send real-time information. But before we go into the system overview, we have to first illustrate what is LiFi and how does it work. Well, LiFi is a visible light communication-based technology. It was firstly introduced back in 2011 by a professor called Harold Haas. Basically, it's a relatively new wireless communication technique that enables us to send data. The data could be message, a text medium, audio, or even images. How does it work? The data is transported by the light, encoded in subtle changes of the brightness, and detected by a photodetector. If we look around, we have many LEDs around us. So there is already a rich infrastructure of LiFi transmitter all around us. The thing about this technology is that it has many applications. It can be used for vehicle-to-vehicle communication, vehicle-to-infrastructure, and it can be even the new Wi-Fi in our homes. Now, the system overview. In our application, we will utilize this technology in order to send real-time warnings from the police vehicle to other vehicles in the road. So let's imagine a scenario where there is a vehicle driving dangerously and suddenly swerving through the lanes. It could be tailgating, running, or cutting the traffic signals. Eventually, this could lead to disastrous effects, not only in this particular vehicle, but on others as well. So our idea is that a police vehicle could notify violators by sending out real-time warnings using the equipment we plan to install in the police car. The violator will receive the warning in a manner that does not interfere with their driving. Later on, the violator could access and view the full details of the incident via a mobile application we developed.
Hello everyone, my name is Yazan and in this section we'll demonstrate how all components are interconnected and communicating with each other, and we will show the final design of our prototype. The structure shown represents two subsystems, a police vehicle, in other words LiFi transmitter, and a receiver vehicle. The transmitter has a microprocessor that controls the other components and guarantees a two-way connection to the cloud for the aim of extracting pre-existing warning messages. The transmitter will be equipped with a light source to transmit the warning messages to the targeted car ahead, and on the other side, the photodiode will detect and record the fluctuations of the laser light emitted from the transmitter. And finally, the microcontroller will output the message accordingly using a visual display. The proposed framework requires both the transmitter and the recipient to be in line of sight for the information to transmit appropriately. Starting by the LiFi transmitter. We have used a Raspberry Pi mainly for the police officers to interact with the cloud mentioned earlier, using an external display, and a GPS module was used to record the location of the incident. In addition, we included a joystick module to accurately aim the laser light on the receiver photodetector. The rest of the components can be visualized throughout the prototype image of the LiFi transmitter. Moving on to the LiFi receiver. We will have an Arduino Mega connected to a solar panel to capture the message sent throughout the laser light. We will also have an LCD display that will display the decoded message, and a voice announcement will be played to notify the driver of a potential warning. In the previous sections, we discussed the concept of LiFi technology, how it works, and its different applications. However, in this subsection, we will mention how we implemented the communication protocol by utilizing the LiFi technology. Much like any wireless communication system, timing and establishing synchronization are essential requirements for the communication to work properly. Having said that, our proposed design needed timing synchronization for the communication to operate in the right time and order. So let's take an example of a police vehicle wanting to send a warning message stating driving dangerously. Our communication protocol starts by setting a sequence of bits to be sent at the beginning throughout the laser beam to synchronize with the receiver. After guaranteeing the synchronization has been completed successfully, we will transmit the length of the message. This length can be used later in the receiver system to stop reading once the complete message has been sent. Finally, we will start transmitting the complete message bit by bit throughout the laser light. We also used a CRC error detection mechanism to detect any errors in the transmission. Each message has its corresponding remainder that is calculated using CRC algorithm. Once synchronization is established between both vehicles, the receiver will start recording the message details and decode it into a text format to be displayed on the LCD display. As you can see, the warning will be displayed on the dashboard of the vehicle. Moving on to the results section. We tested our LiFi communication up to 8 meters, over 100 times under different scenarios, as mentioned in the graph. The graph illustrates the remarkable results we achieved, and here's a demo video showing the full communication. We first tested our LiFi communication from 3 meters apart, and as we can see, we have successfully achieved the message, stating multicolor lights. And for the next test, we tested our transmission from 8 meters apart. And also, as we can see, we successfully received the message.
Alright, thank you Hassan. Assalamu alaikum wa rahmatullah. Now I'll be talking about the advanced system features. We wish to add some additional features and extensions to make our idea even more comprehensive, and in order to maximize our prototype efficiency, we decided to use computer vision to recognize the license plate numbers of the violator's vehicle. The steps to do so are as follows. We first capture the image and resize it. Following that, we convert the image into grayscale and smooth the edges to reduce the noise. Next, we have to find the edges of the number plate and crop it to a new image. Finally, after completing the previous steps, the remaining step is to use a valuable Python library called pytesseract to extract the plate number. The following demo video illustrates how we did so. We mentioned earlier that we developed a mobile application for the violator to later access the incident details in depth, and you can observe it in this video. So, hosted a cloud database in order to fetch and edit data from and to that central repository of the data that we used then.
The journey does not stop here. Many different adaptations, experiments, and enhancements have been left for the future due to the lack of time. Error correction technique is one of them. In our project, we used an error detection mechanism which have helped us in discovering whether an error occurred during transmission or not. For example, this is a sample of a failed attempt in transmitting. As you can see, the problem occurred in only 2 bits out of 152, so the error rate is very small. and by using an error correction mechanism, it can detect and reconstruct the original error-free data and guarantee us better accuracy and results. Secondly, object detection. Another enhancement could be detecting the solar cell in the violator's vehicle and automatically adjust the laser direction accordingly. Finally, the concluding remarks. We believe that there are still a number of limitations in our design, but we are confident that our project could go somewhere. With some determination and in future enhancements, it could even qualify to being a high-demand product. That's it from us. Thank you for listening.